today's note, we are just basically going to do a summary of the investigation into graphing or exploring quadratic relations through table of values. So we're just going to summarize kind of what we should have found, or some of the key things we should have found from that investigation. So the first thing, the degree of any quadratic relation, and this was the general form that we looked at during that investigation, y equals ax squared plus bx plus c, where a doesn't equal 0, is 2. So when we talk about the degree of any relation, we are looking at what is the highest exponent value. And in this case, the highest exponent value is 2. And we're looking specifically the exponent on the variables. So in this case, the highest exponent value in any quadratic relation will be 2. If you have anything higher, it will not be a quadratic. If it's lower than 2, that would have to be 1, which means it's going to be a linear relation. So that's a key thing to look for when you're looking at the equations, is just what is the highest exponent on the variable that I see. Is it 2? All right, then I know it's a quadratic. Anything else, it's going to be something that's not quadratic. The graph of any quadratic relation is called a parabola, or parabola, however you want to pronounce it. But a parabola is basically that U shape, or that kind of N shape that we see with our graph. And the key thing is about this is that it's symmetrical. Right, a parabola, it's symmetrical on both sides of the vertex, or that axis of symmetry. The maximum or the minimum value, of a quadratic relation is also called the optimal value. And the optimal value of any quadratic is basically the y-coordinate of the vertex. So that's something that we saw, that the optimal value was that y value of the vertex. If the value of a in this equation, or this general form, is positive, then the graph opens up. That's something we may not have seen, or based on what we were answering, but we did see the difference in opening up and opening down. So now if you go back and look at it, you would see that the value of a in those ones were positive. When the value of a is negative, it opens down. The vertex lies on the axis of symmetry, and the coordinates of the vertex, or if the coordinates of the vertex are h and k, right? So if we just generalize them, instead of x and y for any point, we're using h and k for the specific vertex, then the equation of the axis of symmetry is, it's always going to be x equals, because that's the equation of a vertical line. And in this case, when x equals the x value of a vertex, or h. If the parabola crosses the x-axis, the x-coordinates of these points are called the zeros, the x-intercepts, or the roots. So we've seen x-intercepts before, we should be familiar with that term, but now we're adding in zeros and roots as another term for x-intercepts. And then finally, the constant c of the form y equals a x squared plus bx plus c is essentially the value of the y-intercept of the parabola. And the reason for that is that, again, the y-intercept is basically going to have an x value of 0. So that means if I plug x equals 0 into this, I essentially get, well, 0 squared is 0, 0 times anything is 0. Same with the second one, 0 times anything is 0. So that's where I get that the y-intercept is basically my c value. So again, this is just kind of a summary of what we should have gotten from that investigation, just talking about some of the key points of our parabola, where they're located, and how we can find some of them.